test on all of them to see how well this model that you've learned performs. Okay. So now, what I'd like to do is kind of get a similar block for other learning methods that you've seen. Okay. So you've seen transfer learning. Yes. Yes, you've seen transfer learning. Okay. So let's see who can maybe draw this block. So what we are looking for is, so that's the top block. You still have, let's say, your learner, and then you have your test setup. So for transfer, so can anyone volunteer? There's no points for this, just so we can make it a little bit more fun. Anybody like to volunteer? It's good to make mistakes, so we can learn together. Anyone? I'll have to pick, otherwise. Come on, someone. Yes, anyone? First benchers, or maybe the last benchers. Last call. I can also give you chocolates here. There you go. Chocolate number 1. Yes, please come. It doesn't have to be correct, yeah? I'm just trying to see what people are thinking and what. Please, thank you. Okay. So what we're trying to do is kind of model how transfer learning looks. So let's say there are just 2 tasks. Okay. Yeah, you can just draw the block. You need a microphone? I can't seem to make this work. Okay. Okay.
So we have some distribution, and we have already trained network on this distribution. So we have X and Y in play. So now we want to fine tune the model. So we take the data set from the same distribution and then fine tune the model, and then maybe get our data.
So yes, this is kind of related to transfer learning, but I can give you your chocolate. That's good, but I was looking for a slightly different one, but what you said is also, you can take your place. Thank you. So what you said is related to what I'm saying, but we're going to look at it in a slightly different way. So here you were talking more in the perspective of a neural network, but then we can look at it in the more sort of general perspective of just any learning model. Okay, so here what I'm doing is I have an initial model that is learned. So as you said, it can be a neural network or it can be any other machine learning algorithm. And what I've done is simply trained it on for the task 1, essentially meaning I've trained it on data set D1, and that gives me the model that has been learned. So now what I'm going to do is consider another task where you have data coming from this data set DT, okay, for which you have a learner that is available. And what I'd like to do is transfer all the knowledge that has been learned from the initial learner to another one. Okay, so I'm kind of slowly moving towards a setup where you have an initial existing model, and then I now want to move to a different set or a different model which will work on different data set and a different task. But I want to use all the information that I have from my initial trained model and then just simply transfer the knowledge. So what you're saying is one example of transfer knowledge, which is fine-tuning, where you have in this case a network that has been trained on some initial data, but then you want to use the same network as sort of a starting point and then add new data to then move on to finally this task. So here is the setup, which is sort of more generic, where you can have different kinds of transfer. And finally, once you have transferred all the information from, let's say, your task 1 to this task T, you can then simply finally test only on data that comes from this particular task. Okay, so the final goal is to be working in the space of this task T, which means the data set DT. Okay, so that's the thing that we're doing. Okay, so this again is very related to the next one. So another volunteer, domain adaptation. Yes. Oh, sorry, question or domain? Okay. Yes, please. This is good. You should do more. There you go. Yep. Okay. Okay, that is almost perfect. Thank you. Okay, so this is essentially, the domain adaptation. Here you have kind of different data sets that are coming in, and you want to essentially learn a single learner, which will take data from these two and then learn it jointly. Okay, so so here the thing that we should notice here is, and the notation is slightly different here, is we have essentially the same task. Okay, so here is a problem of, here is a subtle difference between, let's say, multitask learning and domain adaptation, where in the case of multitask learning, you have different tasks, TI, but in the case of domain adaptation, you just simply have the same task, okay? For example, if you want to do, let's say, object detection, so you want to detect objects in a given image, but here, let's say that initial model that you have trained was trained on for one of the data sets, for example, Pascal VOC, and now you finally want to test it on, let's say, medical images. Okay, so here the task is the same, but the data and the domain from which this data has come is variable. Okay, so that is this kind of subtle difference between, let's say, multitask learning and domain adaptation. So now the next one, yes. So in transfer learning, yes, in the general case, transfer learning, the task is also different, but you can also see cases where it's the same kind of task, but the data is different. So it is not technically transfer learning. That's more called as domain adaptation, when you have the same task, but you have just different data and different data distributions. So transfer learning is more for, let's say you have the task of object detection, and you want to then do, let's say, the segmentation of objects once you have detected them. So you want to transfer all the knowledge that you have, and that's typically what is done with neural networks, where you have a pre-trained network that is for image classification. You use that as a starting point, and then you do object detection, image segmentation, etc. So okay, that is more the transfer learning. Okay, so the next one, you have just seen it, about, let's say, an hour ago, meta learning. So maybe, I guess, in the interest of time, I'll kind of give you some of the blocks. So meta learning is the one, I don't need to repeat, you just seen it about an hour ago. So here you have several tasks that have been sampled, and then finally you have another test task that you're trying to test your learner on. So that's the meta learning setup that you've seen. So there is another one, which is online learning, which I don't know if you've seen already, is a setup where basically the data keeps coming, sort of in a streamlined fashion, and then you keep getting data as and when it has been produced, let's say. And so the question here is this like RNN? Not necessarily. So here RNN is has some sort of temporal or sequential thing that is going on here. Here it's just samples that are coming one after. So there is, well, okay, that's a subtle point of view. There is no memory. So ideally you would like your learner to use the memory, right? So a learner is some sort of a memory representation of all the data that you've seen, not just literally copying the data, but some representation that has been learned from all the data. So internally, what are the specifics of the model? So for example, RNN could be one way of maybe dealing with this kind of data, but you could have other models. So it's just a generic setup where you get data in a streamlined fashion, one after the other, the samples keep coming, and then you'd like to learn the learner for all of these samples